Okay, so this is where we stopped in class. So example 10, identifying characteristics of a function. And this is kind of what we're going to be doing with a lot of our study of functions, is identifying characteristics, finding out things about the function, how does it act, what is it doing, what are the important parts about it. So this is kind of just an introduction to that. So we're going to use this picture, this graph of this function f, and we are going to answer these questions. So determine f of 2. So f of 2 happens when x is 2. So the question is, what is the value of the function when x is 2? So there's 2. So if you look at the function itself, the graph, you can see that it has a value of 5. So basically that is saying, if x is 2, what is y? And that is 5. So f of 2 is equal to 5. And then determine f of negative 5. So if you look at when x is negative 5, and you look at the value of the function, you look at the graph, you can see that it has this empty hole there, and that means that there is no value of the graph when x is negative 5. That's not on this function. It's not part of this function. So basically what it's saying is negative 5 is not in the domain of this function because there's no value for y when x is negative 5. So this would just be the empty set. So you could put the null set or the empty set for that because it is not on the function. There is no value for the function when x is negative 5. So find all x for which f of x is 0. So basically, when is the function's value 0? When is y 0? And that is when we're crossing the x-axis, which is when x equals negative 4 and 4. So find all x for which f of x is equal to 0. That would be x equals negative 4 and x equals 4. Then find all x for which f of x is 3. All right, well, when is the value of the function 3? That is when your y value is 3. So it's up here, and that stays 3 all the way over to that point there. So the function has a value of 3 from x equals negative 3 all the way up to x equals 1. So all the values between x equals negative 3 and x equals 1 have a function value of 3. So all x, that would be, the answer would be the set of all x such that x is between negative 3 and 1, including negative 3 and 1. So we would say negative 3 is less than or equal to x, which is less than or equal to 1. And if we were going to write that in interval notation, we would write negative 3, whoops, sorry, that needs to be a square bracket. We would write negative 3 up to 1. And that would be the set of all x for which f of x is equal to 3. So now we're going to determine the x-intercepts, and that is very similar to part C, but now it is asking for the actual points where this graph crosses the x-axis. So those 2 points are negative 4, 0 and 4, 0. Okay, and then part G says determine the domain of f. So the domain is all of the x values that have y values on this function. So if you go from left to right on your x-axis, you can see that the smallest value of x that's on this function is going to be anything greater than negative 5. So it doesn't include negative 5, but anything greater than negative 5. So the domain is going to be all x such that x is greater than negative 5. And after that, it can just keep going because all the values going up from negative 5 will have y values on this function. The arrow just keeps going and going, and even though it's mostly going down, it's also continually going to the right. So it will have any x value you want. So another way to write that, of course, is negative 5 to infinity. And so that would be the domain. Then we have determined the y-intercept. So where does this function cross the y-axis? And that is right there, when x is 0. So that is the point 0, 3. And then determine the range. So the range is what y values have an x value on this function. And so if you start at the very bottom, there is no, it goes down, 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 down forever. So there is no limit on how negative and how small y can be, but y never gets higher than 5 on this graph. So the range is going to be the set of all y such that y is less than or equal to 5. Every other y value is possible because you just keep going down. And then another way to write that would be negative infinity to 5, including 5.